The last thing that we need to be able to do in section 2.3 is to analyze propositional arguments. So a propositional argument is going to be valid if and only if. Okay, so here we have this special conditional, it's called the biconditional, where it's going to work both directions. But if and only if it is impossible for the premises, if you assume them to be true, to result in a false conclusion. Let's take a look at an example. If I go to the movie theater, I will choose to watch a comedy. I went to the movie theater, therefore I watched a comedy. Well, how would we analyze this? Well, first, let's start by writing the first premise. If I go to a movie theater, P, then I will choose to watch a comedy, Q. Our second premise was P, I went to the movie theater, and our conclusion here was Q, then I watched a comedy. So how can we analyze the statement for whether it is a valid or invalid argument? Well, we look at our truth table. So we look at our first premise, P implies Q. Then we look at our second premise. We have to match up the row that this corresponds to. Here, our first premise we assume to be true. Our second premise we assume to be true. So you're looking for the statement where they're both true. Now, go back to the beginning. What was the case with Q? It was true. So here, since our conclusion had to be true, then we had a valid argument. So we're using this truth table in a little bit different of a way than we did before, but we're still creating a truth table with Let's take a look at how we would use the truth table to determine if this was a valid argument. So you start with your P and Q statements, the true, 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 false, false, true, false, false, that we always use for two statements. Now, the first premise in this argument was a P implies Q. So here, your conditional would be true, then false, then true, then true. What I want you to do now is looking at that first premise, we're assuming it to be true. So we will not consider the second row anymore. We also are going to consider the second premise to be true. So look at the P statement. Where do you have both the conditional true and P true? Well, that only happens on this first row. Now we look at what's going on with the Q for that particular line. And in this case, the Q was right here as true. And so this would be a valid statement because you had a true first premise, a true second premise that forced the conclusion to be true. That is an example of a modus ponens, which in Latin means a mode that affirms. So basically, the second premise affirmed the P part of the first premise. It said, hey, the P part is true. And so that is going to be a valid form for an argument. There are several valid forms, and when you recognize this one, you can automatically say that it's valid without doing the truth table. Now take a look at another argument. If children are allowed to drive, then the roads will be safe. Children are allowed to drive, therefore the roads will be safe. So here, P is going to be children are allowed to drive, and Q is the roads are safe. This is another example of this modus ponens, and so we automatically know that it's going to be a valid argument. The problem that students sometimes have is that they look at this and they say the argument is bad because the premises are false. Well, yes, it is a bad argument because it was false premises, but we're only talking about logic here. Logically, it is valid. Valid simply means that if the premises were true, then the conclusion has to be true. And that is not violated here. We're not talking about whether the argument itself was true or false. We're simply looking to see if it's valid. Let's take a look at the example. If I go to the movie theater, I choose to watch a comedy. I chose to watch a comedy today. Therefore, I went to a movie theater. So symbolically, we can look at this argument as P implies Q, our first premise, but here our second premise is the Q statement. I watched a comedy. And our conclusion in this case is P, that I went to the movie today. So if we put this in a truth table, what we're looking at is our P and Q statements, all of our combinations. The first premise is that conditional. So we have our true, false, true, true. But our second premise was Q. Look at the Q statements. Your options are true, false, true, true. So we just write that again. And then for all of these combinations, our P statements would be true, true, false, false. So I want you to look at the combination where both the first and the second premise are true. Here, you have this first row that qualifies and this third row that qualifies. One of them leads to a true conclusion, one of them leads to a false conclusion. So since it was possible to have a true first premise and a true second premise, but a false conclusion, that's going to make this an invalid argument. This is an example of the fallacy of the converse. So you started making the converse by affirming that second part, the consequent, but it ended up being an invalid argument. So if you ever notice this one, P implies Q, but you assert Q, you can automatically say it's invalid by the fallacy of the converse. We can also restate this example just a little bit. If I go to the movie theater, I will choose to watch a comedy. I chose not to watch a comedy today, therefore I did not go to the movie theater. Looking here, we have P implies Q, but then we had not Q. So if we look here for our first premise, P implies Q, we have true, false, true, true. Our second premise, not Q. Well, let's negate Q. We would get false, true, true. Looking at the first premise, the only time that you had a true and true first and second premise is this last line. And here, our conclusion is not P. So what would not P be in this case? It would be a true statement since P in this situation is false. So here we have a valid argument because we have a true premise first, a true second premise, and a true conclusion. This is the modus tollens, which is a mode that denies. Anytime your second premise is not Q, you're going to have a valid form of reasoning. So here we look at 5 forms that you might encounter. 3 of them are valid. Modus ponens, where you affirm the antecedent. The modus tollens, where you deny the consequent. And then this transitive reasoning. P implies Q, Q implies R, therefore P implies R. You kind of can cancel out that Q that's happening and go straight from P all the way to R. There are 2 fallacies, the fallacy of the converse and the fallacy of the inverse. We didn't do the fallacy of the inverse here in this video, but if you start with a not P statement for the second premise, then the conclusion not Q is not necessarily true, and so therefore it's invalid.